Welcome back, electricity and magnetism students. Today we're going to review some more calculus, the product and the quotient rules. But before I begin, I just want to remind you that you're watching this video for credit in Edpuzzle. Also that you're watching it during class time because I'm going to be watching the progress bars. That's going to be part of the attendance for the class, which is a requirement of the district. So don't just wait till tonight to watch the videos. Watch them during the class time. And again, that's going to be the attendance. So watch the videos and record the notes and then submit photos of your notes. That's one assignment, just submitting the notes, the photos of the notes presented today. The second assignment is obviously the homework. You solve out the solutions to the questions and then you put those photos into the Google Classroom stream, and that's another credit for today. So that's how we're going to move through the topics, 2 assignments per day in a sense in Google Classroom. So let's begin with what the product and quotient rules are. I've written them down here beforehand. The product rule, if you have 2 functions that are multiplied by each other, like maybe this is sine of t and this is t cubed. Okay, so we have 2 different functions. We're going to take a derivative of that product. The way you do that is you take the derivative of the first function and multiply by the second, and then take the first function and multiply by the derivative of the second. So, the product rule. The quotient rule, what happens if you have 2 functions divided by each other? Like, for example, maybe we have sine of t divided by t squared. Okay, what you do is you use this rule. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, that's the quotient rule. The first example I'm going to do is, so the video will pause now and you can copy this down. Okay, the first example that I'm going to do out is right here. I'm going to do 2 examples today. Here's the first one. We've got 5 sine of 3t plus 7 times cosine of 3t plus 7. So 2 functions, sine and cosine, multiplied together. So we're going to use the product rule. So let us begin. Okay, so first of all, the 5 is a constant. We could just leave that out of the process in the front here. And the first thing I'm going to do is take the derivative of the first function. What I'm going to try and do is maybe color coordinate this. Maybe it'll be a little clearer. So okay, so derivative of the first function times the second. Right. And then what I'm going to do is do the derivative of this one now. So I have plus the sine of 3t plus 7, that's the first function, times the derivative of the second function. And lastly, I'm going to close out the brackets for this 5. It's multiplied by everything, times everything. So there. That's the setup of the product rule. Now what I have to do is go ahead and take those derivatives. So the 5 is still out front. The derivative of sine is the cosine function. Trying to think of... Maybe this will make it clear. Cosine So I would be done if it were just sine of t, then the derivative is cosine of t. But it's not sine of t, it's sine of a function, so I've got to use the chain rule. So yes, I do sine to cosine, but then I have to multiply by the derivative of what's inside here, which is just 3. The derivative of 3t is 3, and the derivative of 7 is 0. So there is the derivative of the first function, but then I still have the second function right here, the cosine of 3t plus 7. I'm just going to come to the camera to make sure the green is clear enough. Yeah, I think so. Okay, and then now this set of terms here. Okay, so what I have is the sine, no derivative there, sine of 3t plus 7. And then the derivative of this cosine function, the derivative of the cosine function is negative sine. Okay, now, that would be the answer if we just had cosine of t. But we don't have cosine of t, so we do the negative sign, derivative cosine negative sine, but then we have to multiply by the derivative of what's inside the parentheses. Again, that's called the chain rule. And the derivative of 3t plus 7 is just 3 again. Okay, so... So what I have here is the 3, and the 3 I could remove out of the brackets and leave that 15. But this time I won't have the brackets. Actually, maybe what I'll say is I'll distribute the 5 to the 3 in both places and make 15. And then what I have is cosine times cosine with the same argument, which means I could now call that cosine squared. And that's all of this right here. This 5 distributes to that 3. For the second term, making another 15. And then what I have, a minus sign, right? See, a plus sign and a minus sign. So this is actually a minus. And because these are both the same sine function, I could combine them as sine squared. And there is the derivative of our original function x. Okay. Okay, so I'll pause the video here to allow you to copy this down. Okay, so that's example 1. As I said, we're going to do 2 examples today, so just one more. Okay, moving on to example 2. So what we're going to do is determine Tmax and Tmin for this function. And what I mean by Tmax is the time at which the function achieves a maximum and the time at which the function achieves a minimum. That's the function. If I were to plot this on a TI calculator, it would look something like this. Okay. Okay. So what I'm talking about for t max is right here, the moment that this function reaches its maximum value, and this would be t min, the moment at which it reaches its minimum value. Now this basically utilizes some of the concepts we learned yesterday about the relationship of derivatives to graphs. Because when a function reaches its minimum point, the slope of the function is 0. The function is neither decreasing nor increasing, negative or positive slope. No, it's 0 slope. And here, at the maximum, the slope is also 0. The function is neither increasing with a positive slope or decreasing with a negative slope. It's got a 0 slope at those points. So what we have to do is take the derivative of this and set it equal to 0. That's how we solve this. Now, if we didn't have the shape of the graph, when we figure out this time by following the procedure I just described, for all we know, this could be a maximum, and that would also have a 0 slope. So what we would have to do is take the derivative a second time and then plug in this number, whatever it is, and see that the second derivative here is positive, meaning concave up function, meaning we're at a minimum. And we would plug in this time into our second derivative, and we would find that we have a negative second derivative, a negative answer. That means the function's concave down, we've reached a maximum. But since we have the shape of the graph already, we don't need to do that additional step. So let's just move on to stating our main idea here, that this derivative of this function will be 0 at those 2 points. And so, plugging in the function into this idea, there. As I said already, now we need the quotient rule because we have one function on top, one on the bottom, so that's the quotient rule. So 0 is going to be our answer. Oh, maybe I'll... So I start with the denominator. And then multiply by the derivative of the numerator. So the derivative of the numerator is the derivative of 20t, which is just 20, minus the derivative of 5, which is 0. And I could do this if I wanted to, but why complicate things? I'll just leave that off and close out the parentheses. The denominator, derivative of the numerator, minus the numerator, okay, times the derivative of the denominator. Now this is like the power rule and the chain rule, because what we have is function squared, so we perform the derivative on that. The derivative on function squared is 2 function to the 1 power. And the function is this. 2 function to the 1 power. But since it is a function, we've got to use the chain rule, so we multiply by the derivative of what's inside here. And the derivative of t squared is 2t. And the derivative of 1 is 0, so I could put plus 0 here, but I'm not going to keep things more simple. And then I divide the entire thing by the denominator squared, which is to the 4th power instead of squared. Okay, now, I've got to solve this for t. So there's a lot of different ways you could do this, but I'm going to try and make it as simple as possible. First thing I'm going to do is multiply by this denominator to the other side, because this is never 0, no matter what value of t I put in. So I can multiply both sides by that function without distorting the or making the equality no longer true. So that just leaves me 20 and then here minus 4t and then our two functions and there. So once again, I could now divide by this t squared plus 1 because I see it in two different places. I could have done this and done, but I think it would have been confusing to some people. I think this is a little simpler to see. So when I divide both sides, 0 by t squared plus 1, it just leaves me 0 on this side. But on this side, it eliminates this and eliminates the squared. And now I'm going to proceed to the solution, but let me pause here for a minute to allow you to copy this down. Okay, so I'm going to make some room to continue on up here, but I'll save that bottom line. Okay. So I have 0 on the left side. And then I'm going to distribute this 20, giving me 20t squared plus 20. And then on this side, I'm going to distribute this negative 4t to the 20t, giving me negative 80t squared. And then this distributed, the two minus signs give me positive 20t. Well, I could simplify this by dividing both sides by 20. First of all, this is negative 60t squared right here. And so when I divide that by 20, I get negative 3t squared. And then I have plus t plus 1. Okay. So to solve this, I could use a quadratic formula. So t equals the opposite of b, which is 1 here, plus or minus radical b squared minus 4a c all divided by 2a, which is negative 6. 2 times negative 3. And I could just punch that on a calculator, and basically what I have here is, well, let's see, how do I want to do this? Yeah, I could say 1/6 plus or minus plus, because of the minus sign, doesn't matter. But radical 1 plus 12 is radical 13. So there are the two roots, one of them being negative, because radical 13 is like 3 point something. So, and this is less than 1, so we have plus or minus 3 point something from 1/6. So that gave us that, as I said before, our negative root, our negative root and our positive root, right? So there they are, okay? All right, so, oh, I forgot the 6 here. Okay. Now, I have those as numbers. If you're interested, negative 0.43 seconds or 0.7 seconds, 0.77 seconds. Okay. Okay, so I'll pause the video and allow you to copy the rest of those notes. Okay, so that's it for today. We just reviewed the product and quotient rules, how to take derivatives when you have two functions multiplied by each other or one function divided by another, product and quotient rules. Okay, so I'll see you in the next lesson on Monday or Tuesday.